Hello, Gael, thank you. I hope you can all hear and see me.
Yes.
Um, Thank you, Heron, as well for your presentation, which opens the way to mine. I will talk about, just one second, okay. I will talk about a work that was done officially for Copernicus through a project which runs, I think it ran in parallel with the one prepared and presented by Jerome, which was financed in Horizon 2020. I will dedicate time only to a part of the project which I was in charge for, which was specifically about the coastal flooding database building. And I will show you the conceptual framework that was behind it, the challenge of doing this at the European scale. Keep in mind, bear with me, that we are at the European scale. So we have to ensure there is homogeneity of everything that is produced. I will deal specifically with a numerical model, a finite difference model, which is a standard used in Copernicus for EFAS, for the river component. Of course, we had to prove that the model was working at that scale, and this was part of an operational system, of a proposal to Copernicus to build a European system for coastal flooding. This was the name of the project. It was a proof of concept. We were not charged for putting up a European system, because that obviously is with the service providers. Was a rather small project which ran for 2 years from January 2021, so has been finished for some time. You can see it was coordinated by Dr. Carmaroli at the University of the School of Advanced Studies in Pavia, and it involved a number of service providers like Mercator, CLS, and universities, as well as, in my case, it was a consortium where Ferrara is part of the university from. You can see the map of the partners. What was the challenge? The idea was to use Earth observation and non-Earth observation products produced by the Copernicus services. And as Jerome said, when you do these kind of things, you have to go through a co-design and co-development exercise. In this case, was officially done through the Copernicus user-based community. And the idea is to go operational. So to produce an operational system which, given a provision of forecast of waves and tidal levels and sea levels, storm surge, produced by the Copernicus Marine Environment Service, we would then be able to produce not only flood maps, but also impact maps. Obviously, I will not talk about these. I will mention where you can find this information from. I will just focalize on the flood. We also produce an automatic shoreline mapping tool, which runs in a similar way to others. It's a new tool. I will not mention about this, but you can find it at the links. And the idea is to propose to the Commission a roadmap for integration into the Copernicus Emergency Management Service that you are all aware of. Why I said it's a challenge? Because it is a challenge to build the operational service at that scale. First of all, you have to identify appropriate modeling approach. You have to set up the model. I mentioned that you have to build a brick by brick flood layers at the European scale. And then you have to prove that all this work works reasonably fine. And then what you can do, you can use instead of using a real operational system given the scale, what EFAS, the river system, does uses a flood catalog, which is what we did in the same way. You then are able to issue warning and produce flood layers, but also impact layers on population, infrastructures, and so on. We use this code, listFloodFP, is an open access code, very much used for river flooding and coastal flooding these days. So what we did, first of all, we chose 17 test cases and tested 72 settings of the model. I will try not to go too technical, but you can find in the links I give you all the information if you want to go deep into it. Then we have to calibrate against observations. There are observations by satellite imagery, Copernicus Emergency Management Service activations, but we also built a historical database of floods using any sort of information, including local observations and citizen science observation too. You can find again in the project description of these, and soon this will be released at the European scale. And the forcing is provided by the Copernicus Marine Service, and all the other information on land use and so forth is provided by the coastal land use cover, which was mentioned by a speaker before. Then for a number of cases that you can see here, we did calibration and validation. We did a sensitivity analysis to choose which was the best and reasonable model setting at this scale. I will show you one example, but they can all be traced. These are the cases we set up work on. You can see they're scattered a little bit around Europe. These are the number of the storms that we tested. Oh, I'm sorry. Why? Okay. These are the number of events, the reference, and the oceanographic region. The forcing part was all coming out from the Copernicus service. You can see here the different settings. You know that the European scale is an assembly of different models. And specifically regarding the setup of the flood model, we tested these three resolutions. We tested a different type of floodplain solver that you can find in the model. We tested different land use friction coefficient. This is an important parameter because very much controls the flooding. And we tested a set of wave setup formulations. Now, the good news is that you can use, as we did, a very basic formulation like this. Basically, you just work on the wave height. The bad news is that you cannot use more specific solutions like this one that is very much of a standard, because the problem is that the most critical part that you need information from, which is in a very shallow water and the up part of the run-up, there is no data because the global models, the DTMs, don't have enough resolution. So we came to the conclusion that it was better to use a very coarse approximation of run-up. If better data becomes available, that can be improved, obviously. So I can show you, here is an example of a very famous flood, I'm afraid, from my French colleagues, was mentioned before, Xintia in 2010. There is information from satellite imagery. This is the comparison between the model that we set up and observations, but we also used local observation that we have in this database that will be released, point observation. This was an approach that was used in all test cases. If you want to find out more about the different model configuration and the choices we made, of course, you can find the reports if you go to the ECFAS website. Everything is open and available on Zenodo, in fact. But I'll recommend you, for the ones who are more interested in the scientific part, to go and consult this paper, that you can keep track of the scientific choices we made. Now, why a flood catalog? The flood catalog produces water depth and velocity maps, impact layers, and can be used using a forecast of the total water level. So basically, you can also say, okay, I have this prediction of this total water level. I go into my catalog. I find the most similar situation to the one predicted. In the catalog, I also have the expected impact, as I told you, not only the flood map, but the impact maps. And I can use that as a warning. Then you have the issue of producing these, showing these. You have to do some data aggregation, of course. Remember, the scale is Europe. And we decided to aggregate the maps at the level of the NAS3, which is the regional definition of regions used for the land use mapping. We have to segment the whole coastline of Europe in segments which made sense. So we have to do a lot of, using a global shoreline, you have to do a lot of checks that it makes sense. And then to set up the model for each segment using the land use and the dam produced by the Environment Agency. It's an official dam for the coastal zone. This is the typical output. If you go to the ECFAS website, there is a lot of information with us that we're showing the system ran for a couple of years. It's not running anymore because the project is over. But you can see our proposal of the flood system is not necessarily what you would become if this becomes a Copernicus service. But you will have water velocity, which is obviously an important parameter, but it's not calibrated. There are no observations of water velocity normally during a flood like this, when instead there are for the water depth. The flood catalog is for over 500 sectors. For each sector, there are 15 scenarios of combinations, also with return period levels of events. This is the information that I will direct you to, that you can download from Zenodo and compare it and use it, not only for operational work, but also for flood estimation, in fact. This is an example for the Cardiff storm case, for the Emma storm in Cardiff. So we were producing these flood maps, and we were comparing with the observations. This is a place where there are observations, in fact. So this is the same approach that was done for every test case. Then we have to move a little bit away from the flood database. You can go and have it, but how we were proposing to use it at operational level. That you see, this is, you can see there is the forecast for CMEMS. Then for every coastal point in CMEMS, we identify where a threshold is exceeded. We did some work doing a reanalysis and choose the thresholds. And then the thresholds for 20, 50, 100-year return scale period identify the coastal sectors that might have problems. Then for every sector, we propose a system could pull out the flood and impact layers, estimate, and then do an aggregation where you then issue the warning. Green, obviously no warning, red is the extreme. Now, if you look at the work, all the documentation, we believe that this system can run reliably on a 3-day forecast on a daily basis. And this could put up, in fact, bulletins. I'm not going too much into detail into the flood calibration and quality assessment. You can find that in the papers. But you can see the skill score very often was close to 100, which is pretty good for a flood model against observations. Where do you find this stuff? You can find the flood database on Zenodo. On Zenodo, you can find everything. Even the layers we used, that we elaborated, everything is there. You can replicate or enhance this work. This is the paper that you can find also on the workshop website that describes the database itself. In fact, you can find it immediately on today's web page. And for any further information, here you go, my contacts. Go to the ECFAS website. There is a lot of information, also training information, if you want videos and all the presentations that we did and all the links to the download of the reports. If you write to this mail, is still active, and even if the project is over, you will be redirected to the coordinator, Dr. Maroli, which can direct you to who did the specific work of each work package. And I think my time is over, and I open for questions. And thank you to WEkEO for inviting me.
Thank you very much, Paolo, for your nice presentation. So we'll move on to the Q&A part. So right now, we don't directly have a question about your presentation. The first one we have for now is about the previous talk, wondering, so does the coastal models or their output that have been mentioned are available online freely similarly to WEkEO? So if I'm not saying anything wrong, well, or Jerome, you can answer, but most of the models are free, I think.
Well, I don't think they're available, the models themselves on WEkEO, but you can contact us if you want to cooperate and have access to all the information, the references, and so on. So you can contact us. Contact@eosc.eu and my email address, jerome@bendenis.space, and I'll let you know what is shareable and what is available as open source. I'm not sure exactly what is shareable now, and ultimately it could be imported in WEkEO at some point. Yes.
Okay, thanks a lot for the precision.
If I can, Gael, if I can maybe answer to that as well regarding.
Yeah, no worries. Sure.
You know, in the Copernicus philosophy, everything is open and available. In our case, if you go to the ECFAS webpage and from there to all the Zenodo links, you cannot download the list flood model because that is open. You can download it wherever you want, but you can download the grids and all the layers if you want to redo this kind of work at a higher resolution, for example. Obviously, the DEM is the only limitation that you have, but you have a better DEM for an area. You can redo this work as you wish.
Okay, thanks a lot for the precision to the both of you. So, one question about your work, Paolo. Have you used multi-temporal satellite data sets showing the progress of coastal erosion?
Okay. Remember that this work was very much event-driven, right? So what we were doing on the shorelines, we only focus on the events that then we used for the calibration. Having said that, in the project, a new algorithm for shoreline-derived satellites was developed called SITE. If you search, you can also find the algorithm downloadable directly from Zenodo, and you could use that just